Hey everyone, welcome. We're going to talk today about Redpanda and Materialize. I've got Patrick Angelis here from Vectorize.io, the builders of Redpanda, where he's a fast data hustler. And I'm Andy Hattemer. I'm on the developer experience team here at Materialize. So, what we're going to go through today is a quick background on Redpanda from Patrick, and then just a real quick intro or background to Materialize. I think more people are probably familiar with Materialize here. And then a little bit about the why use this stack. And after that, we'll get right into a hands-on demo, walking through how these two frameworks work together. And we won't take up too much time with that because we want to close with plenty of time for Q&A. So let's get right into it. I'll hand things over to Patrick to just give a quick intro to Redpanda.
So Patrick here. So Redpanda is basically a new kind of streaming persistence layer. You can kind of think of it as a distributed database transaction log. And it's got all the safety and durability guarantees you would expect from an OLTP database. But it's the other thing is that we built a Kafka compatible API on top of it. And so you can use it as you would Kafka. And we exhibit in some benchmarks we've shown 10x better performance than Kafka, especially if you're latency sensitive. I would really have a look at Redpanda. And we've also focused on ease of use. And so Redpanda ships as a single binary. It uses the RAC protocol to replicate distributed state. And it's collapsed within that single binary, the broker, the HTTP proxy if you use it, and it also comes with a schema registry, all in that same binary. Finally, I want to say it's written in C++, uses a thread per core kind of asynchronous programming model, and that allows us to achieve the latency and the low latency and high throughput performance that a lot of our customers are asking.
Thanks. And by the way, if as we're going through this, everyone, if you have any questions, drop them in the chat, and we'll make sure to either answer them in line if they're quick, or follow up at the end with answers. And then, so that's Redpanda. To give a quick intro to Materialize, in case you're not already familiar, it's a streaming database that takes in sources of data coming from upstream from Kafka often, so equally well from Redpanda. And it allows users to write SQL views that aggregate or materialize data on your event stream. And the magic is that those views are actually translated under the hood to data flows, and it allows Materialize to maintain the views incrementally in real time. So where a normal materialized view would do a full scan of the underlying data every time it needed to be updated, Materialize only does the work to maintain the view based on events coming in. And so it's much faster and more efficient. So what we're going to go through, before I get to the demo, let's just talk quickly about why we think this is a particularly good stack to use for any kind of data intensive stream applications. I think it comes down to it's a little bit more than just Kafka and SQL. It's both of our companies are taking the same strategy to sort of up-leveling developer productivity, where we're taking these very complex, kind of difficult to work with concepts, and we're packaging them behind very familiar and ubiquitous APIs. In the Redpanda case, Kafka. In the Materialize case, SQL. And I think that's effective. So, by the way, what's under the hood in Redpanda, Patrick mentioned some of this stuff. You don't actually have to know all of this stuff. What you really need to be familiar with is kind of the core Kafka concepts and the Kafka API. On the Materialize side, it's written in Rust. There's a bunch of differential data flow and timely data flow usage under the hood, but you don't actually need to know that. All you really need to know is SQL. And the reason that this is powerful is it kind of up levels developer productivity without incurring the same cost. So if you were to want to build a streaming product in using Kafka or Spark or some of the previous generation systems, you would get an increase in capability, but it would come at a steep cost of hiring niche skill sets or engineering time in the build out, and then engineering time maintaining the infrastructure, and then also just the actual infrastructure costs. And what we think that packaging up this technology behind a very familiar API does is it up levels your capabilities without incurring the same amount of costs. So we think it's, at the end of the day, giving smaller teams the ability to do what companies like LinkedIn and Facebook have done with larger teams. All right, so let's get right into the demo. For the demo, what we did was we just took an existing Kafka demo that we've built with Materialize, and the infrastructure of the Kafka demo looked like this, where we've got a load generator Python script that's updating a set of database tables in MySQL, and that's connected through Debezium to Kafka. So it's sending the change feed of updates from the MySQL database into Kafka. And then the Python script is also sending page views directly to Kafka. So we have a bunch of data to work with in Materialize to materialize some interesting views. So I talk about this in the blog post, by the way, but the actual work to switch from the Kafka infrastructure to Materialize, or sorry, to Redpanda was actually pretty straightforward, because what you're doing is replacing schema registry, Zookeeper, and Kafka with the single Redpanda service. And that's where, you know, you see some of that simplicity that Patrick is talking about, and productivity, where there's just less operational overhead of having to think about and manage these three services. It's now just one. And to give you an idea of what that looks like, so the Docker Compose, this is all running in Docker, by the way. The Docker Compose file for the Kafka infrastructure, we've got Zookeeper, Kafka, schema registry. What we are doing to switch it over to Redpanda is just pulling in the single Redpanda image, and it's taking over the role of schema registry as well as Kafka, and Zookeeper is kind of obsolete. So the important things to call out here about running Redpanda specifically with Materialize are enabling transactions and idempotence. I think this is just a byproduct of Materialize using some of the more advanced Kafka API. So Patrick, correct me if I'm wrong, but this is disabled by default in Redpanda, and in Kafka, I think it's enabled by default.
I can't speak to the Kafka behavior. I believe it is enabled by default, but in Redpanda, you have to enable it explicitly for now.
Got it. So that is really the only specific to Materialize guidance here. Otherwise, this is all standard Redpanda configuration. And let's get right into actually running this. So I'm going to be referencing that repo that I just mentioned, and I've already got it. I think I've already got it built. Yep. So start up my containers. I've got MySQL, Redpanda, Materialize, Debezium, LoadGen, and I'm also going to really quickly just make sure those are up. Okay, those are all up. And before we get into Redpanda, I want to just show what the upstream MySQL database looks like, because I think this was really impressive, at least to me, where getting the Debezium connection to Redpanda was really just a matter of changing addresses. So this is the MySQL database that's streaming changes into Redpanda from Debezium. It's pretty simple. It's just items, purchases, and users. And the purchases table is what has got the most volume, and it's just a join between users and items. So we'll work with that in Materialize, but we're working with the change feed that's coming through Debezium into Redpanda. So on the Redpanda side, when you install Redpanda locally, you get a really nice CLI tool called RPK. In this case, since I'm running it all in Docker, I'm actually just going to exec into the Docker container where Redpanda is running. And you can see a bunch of debug info that'll tell you all of the config and settings. In this case, I can confirm that the two specific settings for Materialize are enabled. And if I do RPK topic list, you can see we've already got all of the topics coming in from Debezium and the page view topic coming in directly. And I can actually, since the page views are JSON formatted messages, I can say page views. You can see we got a lot coming through, and we'll look at this later, but it's important. So these are the synthetic page views that are just being generated by a Python script. But notice that you've got some page views going to profiles URLs, and then some going to products URLs. So we'll also work with that in Material. And then one last thing I'm going to do really quick. I'm going to actually create a topic to use later. I'm going to call this. So you can see, like, coming from the Kafka world, the command line interface for working with Redpanda locally is really nice and pretty intuitive.
I mean, as a transitionary, it would work as well, so we are compatible with the actual, we are compatible even with the admin APIs. There was a question on chat. Will the recording be available?
Yeah.
It will. Okay. And there was another question.
We'll upload it to YouTube. Yeah.
Okay. And there was another question that I mishit the thing. I was going to type an answer, but the question was, will this work with Mirror Maker 2? And the answer is yes, it does work with Mirror Maker 2 and the S3 sync connector.
Cool. So let's get into Materialize. I'm just connecting to Materialize with the pSQL command line and start creating some sources. So when you're using Redpanda as opposed to Kafka, there's really not much different when you're creating a source in Materialize, which is really just telling them Materialize where to look for messages. So you're telling Materialize you're connecting to, in this case, I'm using that Docker Compose setup. So the Redpanda address aliases to the Redpanda container. So I happen to be using that there, but this would just be, your standard address, the 9092 port. And then I'm also pointing the schema registry URL to that same Redpanda container because it's handling both. So creating a source should work fine. There's, at this point, there's nothing being ingested yet. These are just registering the sources. So we can show that we've got these sources saved. And then one thing I'm going to do before we start going further is create just a regular view. So that page view data that I showed before, I want to clean it up a little bit before I start working with it in Materialize. So when you create a regular view, you're not actually processing any data. You're just creating the data flow, and you can reference this view in later. So I'll create that view. And then just to give an example of like a typical data engineering workflow, we'll create a purchases by item aggregation. So this, since it is a Materialized view, has begun to pull messages from Redpanda and process them through the data flow. So if I say select star from purchases by item, you can see that this data is coming through. And I guess in this case, these few purchases haven't updated yet, but it'll be maintained in real time as new data arrives. So let's create a few more views just to get a sense for this. So here's another aggregation of page views by item, and then a big join that pulls everything together called item summary. And now if I look, you can see what we've done is taken the raw messages in Redpanda that are coming from Debezium as change feed items from the database for items and purchases. And we've joined them with the page views and distilled that or aggregated that into a pretty useful data engineering view of item summary, where you conversion rate, which is the number of page views divided by the number of orders, and a bunch of other materializations. So this is able to maintain in real time with no issues and it's doing that incrementally through the data flows. So I know a lot of the people that are using Redpanda are doing it from more of a application context or building actual products as opposed to a data engineering context. So I wanted to give a quick demo of what that might look like. In this case, we're going to create, similar to on LinkedIn, the user profile page where it shows you who's viewed your profile. We're going to do a miniature version of that really quickly. And the first view is going to be the data for the graph of how many people are viewing your profile. And so there's a couple things going on here. The first is a aggregation by user ID. So we're pulling that page view data and looking for the user ID of the profile page that people viewed. And then we're also aggregating it by the received at minute. And then the most interesting thing we're doing here is a temporal filter where MZ logical timestamp is Materialize the equivalent of now pretty much. So this filter is saying only Materialize the page views from the last 10 minutes. In this case, it's converting it to epic seconds with the 1000. So it's at milliseconds. So just to give you an idea of what that looks like, we would say select star from, and we're maintaining the results for every user ID. So we would say where user ID equals 10, and you can see it's only been running for 4 minutes. So it's got 4 columns, but this is the data that you would use to create in your front end a line graph page views to a user's profile over the last however much time. And then to go even further and actually demonstrate another crazy join and Materialize, let's actually pull specific people who viewed a profile in the last, or this, in this case, is just the most recent 10 users that have viewed a particular person's profile. And we're doing this using a lateral join, which I'll link to in the follow-up material. I'll link to the documentation for this, but it's a very intense join where if we've got 10,000 profiles, I think in this test set, it's going to have to maintain a lot more records in memory in order to do this join. So I think it's like a quadratic level of work. And I'm going to just do one last view to actually pull in user emails on here. And now if we say select star from, we can see, we're pulling in for this particular, these other users have viewed their profile or these are the last 10 users to have viewed their profile. So that's all happening, maintained in real time. It's pretty interesting to mess around with the different types of materializations you can do. There's 2 Redpanda specific features I wanted to call out. One of them is the ability to use Panda proxy, which is something specific to Redpanda, where it just gives you an HTTP API for producing and consuming messages from Kafka. And so an example of how we can use that in the Materialize context is something called demand-driven queries, where in this case, let's say you have a very work-intensive view that you don't ever need to reference everything at once. Say it's like a debug or troubleshooting view where you're aggregating a bunch of information specific to a user. You might not need to aggregate all of that information for every user all at once. And so what you can do is you can have a SEP topic in Kafka where you're able to flag specific user IDs, and then you pull that in a join in Materialize. So Materialize is only ever maintaining the results for users that have been flagged. So to illustrate this, we created that DD flagged profiles topic in Redpanda earlier. I'm going to create a source, and I'm actually going to create a Materialize source, which means it's going to process all the data automatically for that empty topic right now. And then as a view, I'm going to just as a demonstration, join it to all of the page views. But keep in mind, since I'm first pulling in this DD flag profiles table, it's going to be empty at first. So If I say select star from, there's no rows yet because I haven't actually flagged any profiles. And I can do that just in a separate tab. Using Panda proxy, I can just push a record to DD flag profiles. And now when I go back here, I can see that has propagated through to Materialize, and I'm able to view all of the page views for user ID 25. And then I can do, again, I can go and change the ID here. And since I'm using the same key, it's only ever going to maintain one. So I can say 20, and now it's only maintaining the results for user 20. So that's using, I don't think it's, particularly, it's not impossible to push records to a topic or push information to a topic from the command line but I think there's just a bunch of extras that Redpanda has built in, like Panda Proxy, that reduce the amount of glue code or extra services that you might have to run. And then one last thing to demonstrate is actually syncing data out from Materialize back into a Redpanda topic. So for that, I'm going to create another view called high value users. And this one, the important bit is it's doing a filter to say only flag users who have spent more than 10,000. So all of their purchases equal more than 10,000. So I'll create that view, and just to give you an idea of what it looks like, we've got a bunch of users that are in there already. And in order to say, send an alert email when a new user qualifies as a high value user, I might sync that out to Redpanda. And I would do that with the create sync. Let me clear this. I'll do that with the create sync syntax. And in this case, I'm doing a couple of special things. I'm using the reuse topic flag, which what that accomplishes is if I were to restart Materialize, it wouldn't re-output the same event of a user entering the high value users. It knows to enforce exactly one semantics. So I'll create that sync, and that will go and create a high value user sync topic in Redpanda. So if I were to go back and list, you can see I've got a high value users topic in Redpanda that's already been created. And I can't actually display it. Actually, Patrick, this is a question for you. If for Avro formatting, the RPK topic consume doesn't display nicely right now, right?
We cannot parse out the Avro at this point and print it in a pretty manner. So I'm wondering, the Avro project may have some tools to do that.
Okay, so one workaround for that, which is just like kind of fun. It's like kind of a Ouroboros style thing. Is I'm gonna actually pull the topic back into Materialize. So I created the sync. It's outputting the change feed of new users entering the high value users query into Redpanda, and then I'm going to pull that back into Materialize so that we can display it. So this is a Materialize source, so it's already processing. So if I just say select star from HVU test, so you can see this is the structure of the message that's output to Redpanda when you create a sync. You've got a before if there's a delete or an update, but in this case, it's all append. So we've just got a after, and you can see each of these is a user that's just qualified for being a high value user. And you can then consume this topic from another service to say, send an email or an alert or something. So that's what I wanted to cover today. I think if you read the article, there's more detail and references for everything we just talked about. All told, I think it's been really fun learning Redpanda and seeing how well it integrates with Material. There's also, both of us have cloud products. I link to the registration forms for each at the end of the blog post. The cloud product should integrate nicely. If you have any feedback, definitely, each of us have Slack communities that are really active. So join in and ask questions or give us your feedback there. And if you find any bugs, I know that we're both very interested in hearing that. And I think Redpanda might even send you some swag. So any questions that came up during the chat that weren't answered?
Or we could take out some new ones.
How does,
yeah.
or Patrick, I was going to say, how does the Redpanda cloud product work? Is it like
Yeah.
MSK or I guess how does it structure?
That's a great question. There's actually two flavors that we're coming. The first flavor is what we kind of more commonly think of as a cloud service. It's more like a SaaS where you go into a vectorized website, and you become a tenant there. And then we can basically provision, endpoints for you that you can hit. And you're going to be charged by throughput and by storage. So in that sense, it works a little bit like Confluent Cloud, where you kind of meter on throughput and all of that. And then the thing there is that your data is basically going into our VPC, going to buckets that are in the end vectorized controlled. And I think for a good majority of like smaller use cases or like occasional use, especially if you have low throughput, that probably makes the most sense. We also have what we call right now BYOC, bringing your own cloud. So basically you have your own VPC. And let's say today we're running on Amazon and AWS and GCP. Let's say you have VPC in either of those two cloud providers. Basically, we have a control plane running on Amazon, and you could be in GCP right at this point. And you install a cluster. And we have a whole wizard that walks you through that, right? But basically your cluster gets installed in your own VPC. And a part of that, there's an agent that then reaches out to our control plane to receive a manifest and basically execute instructions according to that manifest. So the security model there is that there's no need to provide us with any kind of credentials, any cross account roles. We don't get to see the data that you're putting into Redpanda. We have no control over spinning up resources on your side, and then there's no need to configure firewall ports actually, because you have an agent that goes out to vectorized cloud as opposed to us coming into your VPC. So that model is pretty, it's pretty popular with some folks that are, have more sensitive data needs. And that's, I think that's going to be good also for larger workloads and where you want to be able to size your cluster and have a physical allocation like that's under your, more or less under your control.
And I think all of that. So what actually influences the compatibility or the auth compatibility with Materialize is just the auth structure that you use. Basically, I don't think there's actually the way that Materialize handles auth to a Kafka or Redpanda cluster shouldn't actually limit what you're doing there. I think
it shouldn't matter which one. Yeah, if you're going through the fully managed cloud or the bring your own cloud version, it shouldn't matter. I guess the one thing to think about is, egress, but, eventually we will have VPC peering enabled. So as long as you're in the same AZ, probably doesn't matter.
Yeah, we're thinking about that too already. So I think, both of these cloud products are in beta. The Materialize one you can register for and see the pricing. And there's a link. I'll also follow up to everyone who attended with the link to the Vectorize.
Yeah, so the question by Josh, does Redpanda support SSL and topic level authentication? Yeah, so transport level encryption via SSL, and we support the Kafka style ACL. So yeah, both of those work. For the authentication, we use SASL Scram. And if you're using a cloud service, we do. Yeah. I mean, if you're using a cloud service, we do require actually TLS and we do use like public certificates from Let's Encrypt.
Actually, that reminds me, one of the things that I wanted to look into, but we didn't get to is the functionality, which I think I think it's partially already there, or there's two different flavors of it. Is that?
Yes. So there are two flavors of Wasm. There's one that's in the product. These are both in preview mode. But the one on the product right now works on a sidecar model. And maybe I should walk back, and because we shouldn't assume that people understand what Wasm is. But basically, Redpanda is we're working on integrating WebAssembly engine into it. So what it is you can basically take a language like JavaScript, TypeScript. Eventually, we'll also support Rust, Lang, and Go, and whatever else can compile into Wasm. Right, you can compile those languages into a WebAssembly and run that bytecode inside of Redpanda, the broker. And, that on a general level, that allows for extensibility of the platform, right? But at the outset, what we plan on doing is to allow for what we're calling data policies. So the data policies thing is basically a way to, if you can kind of think of it as a stored procedure for streaming, right? It runs transformation code on the side, on the broker side. So that if you imagine you have three different consumers looking at the same topic, and you have some differences in how you want each of them to see it, right? Like maybe one of them is restricted to not view PII. The other one can see only certain rows because, they're based in the US, and, so they can't see rows from Asia Pacific or EMEA, whatever, that sort of thing. Or maybe you have another one that's only interested in a subset of columns. What you could do is set up those three accounts with different ACLs so that a different data policy applies to each of them. And that data policy is basically a transformation of the consumed topic on the way out to that consumer. And so they will each get like a specific view. So that's kind of a great way to, you basically trade, this does take on a bit more CPU cycles because you're applying logic and you're kind of decoding the messages, right? But you could potentially drastically reduce the amount of data that goes out, right? Depending on how, you might be filtering a whole, like let's say 90% of the data on the way out. And so, that trade-off in that situation would.
That's super useful. I know a lot of Materialize users are asking, about ways to just kind of filter before it gets to Materialize, just to simplify things. And so I think that will come in use. All right. Well, if there aren't any more questions, I think we can wrap this up. Thanks, Patrick, so much for your info and context on Redpanda. Really excited about it, and just generally excited about how much it is going to open up the streaming use case by just simplifying it so much. So
yeah, this is, I just want to add, this is super cool, right? Like Andy basically spun up a streaming system in his laptop and walked through all this. You could, and the thing is that the code that Andy just wrote is going to run exactly the same on a production system. So that's what's great about this stack.
Yeah. All right. We'll follow up with a link to the recording on YouTube and some resource links to the code we used in this session and a few articles with more information on some of the topics we mentioned. Thanks, everyone. Have a great day.